Hello everyone, I am Joydon Chakma. I am the host and facilitator of Data and Business Analytics course. Today our first project, our learners, they will explain their project's works. So I want to call one by one. Mutasim Mahmood, please introduce yourself first, then present your works. Basically, before that, I want to explain the project. The project name is Comprehensive E-commerce Data Management and Analysis. This project is fully based on the SQL structured query language. The structured query language, we use a structured query language, and they build this project from the scratch. Basically, they have to build from table from a database to everything, and after that they do some analysis based on our provided questions. In each question, the questions are actually focused on the concept of functionalities of SQL. So in this SQL, from the general functions to the advanced functions, from like dense rank, and rank aggregate functions having group by, these all advanced functionalities are in these projects. They do these projects by doing this by using these functions. So I want to call Mr. Mutasim Mahmood to explain your project, to present your works. Thank you. Mutasim, please share your presentation and explain.
Can my slides are short? Hello.
Yeah, your project is showing.
Okay. Assalamu alaikum everyone. I am Mutasim Mahmood. Today I presented my portfolio project on MySQL Comprehensive E-commerce Data Management and Analysis. Today, our course name is Data and Business Analytics. So now I will talk about our given database scheme. Here we saw a database schema and we saw many relationships between tables. These are order items and order relationships, orders and user relationships, merchant and products, user table details, and countries table, and admin merchant relationships. So if I explain that in one sentence, first one, order items and order relationships. Each order can contain multiple items with the order ID linking them together. And then the user relationships. And each order is placed a user connected through the user ID. Then there are merchant ID and products relationships. Products belong to merchants and identified by the merchant ID. Then there are user table details. The user table holds personal details like full name, email, and country code. Then there are countries table. This table contains country codes, names, and continent details. Then the last one is admin and merchant relationship. Each merchant is managed by an admin represented through the admin ID. So now we go to our queries section. So in queries, firstly I will tell about what I put in the query, then the result came, and then I share my insights. So the first one is total number of orders by each user. In this query, I use a group by clause combined with an aggregate function count to calculate the total number of orders for each user. So the result shown that some users have some significantly more purchases, with user being the highest. This trend shows diverse engagement levels across on user base. So my insights is targeted promotions for high order users could further increase their loyalty. Second one is names of products ordered at least one. So in this query, I use a distinct clause in combination with a join to list all the unique products that have been ordered at least once. So the result shows that a diverse set of products across categories with many items being ordered frequently, suggesting a well-rounded product portfolio. So in this query, my insights are analyzing which products are ordered most can inform inventory stocking strategies. Next one is users from merchants country. So in this query, I used a join between the users and merchant tables, filtering by the country code to reflect users who are ordering from merchants within their own country. And the result shows a significant number of users prefer purchasing from merchants within their country. This behavior suggests that users might trust local merchants or prefer faster shipping times. And my insights are informed local marketing strategies, encouraging users to support merchants within their region by promoting their products more prominently. So our next query is aggregate functions. So the first one is user order quantities. In this query, I use a sum function with a group by clause to calculate the total quantity of orders placed by each user. So the result we show that vary quantity ordered by users with a few users placing significantly larger orders. This indicates a small percentage of users contribute to a large portion of total. And my insights are identifying these high value customers can help in personalizing offers and improving retention strategies. Second one is average order quantity per product. In this query, I use average function in the order quantities, group them by product name. So the result shows that some products have consistently high average order quantities while others have a smaller, less frequent orders. So my insights are high average quantity orders should be promoted or branded more to increase overall sales. Next one is product price range analysis. In this query, I use the minimum and maximum functions to identify the price range for each product. And the result analysis shows a wide price variation in some categories such as electronics, while etc. So my insights are pricing insight can assist in setting competitive pricing and identifying opportunities for discounts. Next one is merchant distribution by country. In this query, I use a group by clause on their merchants country field to count the number of merchants in each location. So if you see in the result, we show that indicate a strong presence of merchants from a new key countries with a concentrated region in like North America and Europe. So the insights are create regional marketing strategies to increase partnership with local and international merchants. So our next query is group by query. First one is order status distribution. In this SQL code, I used a count function with a group by clause with categories ordered by their status like shipped, delivered, processing. Later we saw a graph also. In this result, I see that the majority of orders have been shipped or delivered, so a significant number is still processing or have been cancelled. My insights are that need of streamline order processing to reduce cancellation and processing delays. So the graph is here. Here we saw the order status distribution graph. In this graph, we saw 3 points. The first one is the majority of orders are shipped or delivered. These things are closed. Second one is a significant number of orders are still processing while others have been cancelled or returned. And the next one is there are a few orders in various stages of delivery or refund like transit, awaiting pickup or out for delivery or refunded. So our next query is product count by merchant. I wrote a SQL query to count the total number of products offered by each merchant. And the result shows that merchant A is the highest number of product merchant Arong, merchant Zara, and merchant Center were equal kind of products. So my insights are merchant with higher product counts may have more robust supply chains, guiding future partnerships and resources allocation. Second one is users with high order activity. I filtered users based on their total order quantities using a having clause to identify those with high order uh, activity. In this output, we show that the data, a small subset of users consistently place large orders, contributing significant to overall sales. Now, the insights are targeting these users with exclusive orders or offers or rewards that can help maintain high engagement and order volumes. So this is our next query, and our next query is time-related operations. So the first one is year and month extraction from order days. So in this first query, I used a SQL query to extract the year, month, order days using the year and month function. The result shows that the distribution of orders across various months and years. In this insight, I identified peak order periods, allowing for better inventory and resource planning during the high demand months. Second one is year, order date, difference calculation by years. So the same query was used again to extract year and month from order date. And the output we show that the findings confirm the trends in order volume across different times of the year. So my insight is forecasting for future sales and stock level remains accurate and reliable. The last one of the time related operations are day of the week extraction from order days. So I used a query code dyname function to extract the day of the week from each order day, and the results are showing that orders are most frequent on weekends with a notable dip on weeks. So my insights are marketing efforts and promotion should focus on weekdays when user activity is at its peak level or highest. So the next query is SQL joins, and the first one is inner join. Yes, inner join, and inner join you use the orders with username. In this query, I performed an inner join to combine order details with username from the users and order tables. And the result explanation is outputting each order specific user, providing a detailed view of which users are purchasing specific products. So my insights are understanding which users are buying specific products can help the target repeat buyers for similar items. Second one is left join, products and their orders. So I used a left join to combine all products with their corresponding orders, ensuring even products without orders were included in the result. And the result shows that products that have not been ordered yet alongside those that have not been purchased. So my insights are adjust inventory, offer promotion for underperforming products. The last one in join SQL joins is self join user switch same function. In this SQL code, I used self join on the users table to identify pairs of users who share the same country code. And the explanation shows that they are null because we maintain a equal number of country code. But if there are many, then the my insights are create country specific promotions or localized marketing strategies. The next one is subqueries, and in this subqueries, the first one is users with orders excluding specific group. So first one is I used a subquery with not exist to identify users who have placed orders but never purchased a specific products. In this result, we show that a list of users who have not ordered a particular product, providing a clear view of potential customers for costing. So my insights are target these users with personalized promotions or recommendations to encourage the purchase of the excluded products. Second one is users with above average orders. In this SQL, I applied a subquery using the average function to find users whose total orders exceed to average number of orders placed by all users. And this result the null because there are maximum are equal. But if there are many, then my insights are targeted with exclusive offers or loyalty levers to maintain their high engagement and encourage future purchases. Next one is window functions, and the first one is aggregate functions. And in this aggregate function, the first one is total orders per user with window function. So in this query, I used a window function to calculate the total order per user without resetting the use order. So in this query, the result shows that cumulative total orders for each user and displaying trends in ordering behavior. So my insights are understand which users are buying a specific products can help target repeat buyers for similar items. And second one is average product price across orders. So in this query, I calculated the average product price across all users orders using aggregate functions. And I found that the result displays the average price for each product across the different orders, giving an overview of pricing trends. So my insights are understanding which users are buying specific products can help target repeat buyers for similar items. So now next query is ranking. And in ranking, the first one is user ranking by total quantity order. So the first one, I use a query that rank window function to rank user based on the total quantity of the items they order. And the result highlight the top users who place the largest number of orders, showing a clear hierarchy of purchases behavior. So the my insights are prioritize these high value customers for personalized offers and retention strategies. And the second one is a product price ranking with merchants. I applied the rank function to rank products by their prices within each merchant offerings. And in this result, that we see that the output, the products are positioned in terms of pricing, with some standing out as the most expensive or cheapest within each merchant's catalog. And the insights are informed pricing adjustment, helping merchants competitively price their products. Third one is order ranking by creation date. So I used a row number to rank orders chronologically based on their creation date. And the result shown that the result provides a sequential view of orders showing when such order was placed from the orders to most purchased. And my insights are tracking order patterns and identifying busy periods for operational planning. So the last one in ranking window functions are quantity percentile ranking. So I use the percent rank function to calculate the percentile ranking of users based on the quantity they ordered, and the results are they show that a small group of users fall in the top percentile, controlling a significant share of overall orders. So my insights are high percentile users should be targeted with special promotion to maintain their high engagement. So the last one in window functions are value and analytic, and the first one is next order date per user. So in this query, I used the lead function to predict the next order date for each user based on their previous orders. And the result shows that the expected next order for active users, and these data indicates patterns in user purchasing behavior, and insights are optimized promotional campaigns and customer follow-ups to the result. Second one is previous order price product. So in this query, I utilize the lag function to retrieve the price of a product from the previous order price. And in this output, we show that this shows how the price for a specific product has fluctuated over time. So my insights are inventory management and discount strategies to maintain customer interest. So the third one is first and last order status per user. And in this query, I use the first value and last value window function to retrieve the first and last order status for each user. And in this result, the output shows each user first and most recent order status, revealing users with consistent successful deliveries and those facing cancellations or delays. So my insights are identify users who may need re-engagement due to recent issues, or those who consistently receive their orders successfully. The last one in window functions in ranking is first and last prices in product categories. So I use SQL code in first value and last value functions to track the first and last product prices within each category. And the result show how price in certain categories have fluctuated over time, with some experiencing significant increase or drops. So my insights are offering discounts for products with falling prices or adjusting prices for those with increasing demands. So the next one is case statements, and this case statements, then the first SQL query code is categorize products by price range. So in this SQL code, I used a case statement to categorize product into different price ranges, such as low, medium, high, based on their prices. So in this result, the result provides a clear distribution of products across different price ranges, with the major falling into the medium and high categories. So my insights are which price segments are more popular to set future pricing strategies. And the second one is user categories by order count. So my SQL code is the query a case statement to categorize users into their based on their total orders count, like low, medium, and high. So the result is clarify users into different engagement levels, with most falling into the medium order count there. So a few users are high, but their numbers are very low. So my insights are personalizing marketing strategies, offering high tier users premium benefits and re-engaging low tier users. So the last query code is CTES, and first one is cumulative total of product orders by user. So my SQL code is common table expression CTE along with the sum function to calculate the cumulative total of products ordered by user. And so my output shows that running total of products ordered, allowing us to use the activity trend over time. And my insights are identifying the loyal customers to better result for the company. So this is the graph for cumulative total of products ordered by user, and it shows that some name of Arif Rahman listed the higher total percentage. And the last query code of our MySQL project is top 5 users by order count. And this query uses row number window functions to rank users by their total order count, highlighting the top 5 users. So the data reveals the top 5 users who have made the most orders continuing heavily over sellers. So my insights are these users could be the focus of personalized offers or loyalty program to ensure the continued engagement. So the last one is in a nutshell, we see that our total number of merchants is 3 and the total number of users 10, and product category with the highest sale is electronics, and orders are mostly completed with shipped or delivered status, and average order quantity per product is 5 units, and the next one is the price range of product varies from $5 to $50, and users with highest order quantity show repeat purchase behavior. So the top selling products include laptops and smartphones. The majority of orders come from users within the merchant's country, and the orders made during weekends show a slight increase compared to weekdays. So my SQL project presentation is complete. So thank you everyone. Any questions?
You explained very well, Mutasim. Thank you so much for that, and your aggressive explanation was quite good. And each questions you explained and what can they do, you also recommend in each analysis. So basically, I don't have any questions about it, but I have some recommendation for you.
Yeah,
Uh,
sure.
the the insert keyword. Instead of insert keywords, you can use this once or twice, but don't use this one third time, fourth time, fifth time. Okay.
Okay.
Instead of this, you can use analysis and my
Or
recommendation.
decision
This type of
making.
keywords.
Decision making.
Okay, decision making. This
Yeah.
type of word. Instead of using
Okay.
same keyword every time. Okay.
Okay.
So this is my recommendation for you, and everything is okay. Now, I think that I think your project explanation is well rounded and good. And now uh, I want to call another participants
Yes.
for
Thank you
his work.
everyone, and
Thank you so
assalamu
much,
alaikum.
and close your project, close your presentation. Thank you. And now I want to call Sanjida Akhtar.
Thank
If
you,
you
Bhaiya.
hear online, please please start your presentation and your works. Uh, what you are coming with your presentation. Sanjida Akhtar, are you here? Hello, Sanjida Akhtar, are you listening?
जी भैया.
Okay. Please explain your presentations. Your presentation. Before that, please introduce yourself, then present. Okay. Floor is yours.
भैया আমি একটু ওপেন করছি.
I'm not seeing your presentation slide. Please share your presentation slide, then present yourself. Okay.
भैया দেখা যাচ্ছে?
Yeah, I'm seeing your presentation.
So একটা মিনিট.
Okay, you can take time, no problem. You can take time. You can take your time. You can hide here. You can hide. You can click on the hide button. Just hide link, the underscore hide link. You can click on here. This one you can, yeah. No. Stop not sharing. Instead of this, the right link one, the hide. The right here, the hide. Yeah, that's okay.
So hi, my name is Sanjita Akhtar. Today I'll be presenting my final project. named Comprehensive E-commerce Database Management and Analysis. So let's dive in. So here this diagram shows how different tables in e-commerce are connected, and we see we have a user who have orders, and all the orders are is linked one or more products through this order item. Then we have the merchants that provides.
Yeah, I'm listening. I'm listening you. But you have to write your presentations. It's like
Oh,
presentation. Yeah, presentation mode. Yeah, yeah. That's okay. I'm hearing you.
so we have user who have orders, and all the orders are linked to one or more products to order item. Then we have merchants that provide the products, and all the merchants are linked to products and to a specific country. And finally, we have the product table that contains all the products detail. And lastly, we have this countries table that help us to track the country information related to user and merchant. So all these tables are working together to keep the track of customer and their orders and the products sold by different country, and they are also linked by foreign country. So first one is SQL queries. The first question was to write a query to display the total number of orders made by each user. To run this query, I joined or user and order, then count the order ID, and lastly I group by with user ID and full name. So this is helping me to understand that which users are more active in terms of placing order. So here we can see most of our orders uh, are more active in playing orders and allowing us to analyze user behavior more effectively. Secondly, the next question is to display the number of products that have been ordered at least once. So here I also did the same join on products and order item on product ID. So this is helping us to understand which products are being ordered only once, and can guide us in discussion, in decision making on restocking or discontinuing items. So we can see the most of the products are in cafe category. Then we drive the details of all users who are from the same country. To run this code, I joined three tables: user, countries, and merchants. And lastly, I use the country column. I order by the country in descending order. So this is helping me understand which country code are similar with the merchant ID and the user ID. So this is can be helpful in the target marketing efforts and localized promotion if merchant ID and user ID are from the same country. Then from the aggregate function, here we were told to calculate the total quantity of products ordered by each user. Same, I run three joins here: user, order, and order items, and then group by with user ID and full column. And lastly, I calculate the sum of product quantity to find the total product quantity. So this is helping us to understand that user 1 has the highest number of total quantity order, whereas user 4 and 5 have the same quantity. This is helping me to segmenting the high volume customer or identifying user with the minimum purchase. So those with the higher volume purchase, we can give uh, rewards for their contribution. And those with a minimum purchase, we need to look for the cost or give those customer um, to see why they are ordering less. Then the final, find the average order quantity for each product. So about for this, I join product and order item. Then I average the product quantity, and also I order by the uh, average quantity in descending order. Here I can see the wall curve is the average one, then 4 overkill and phase 0. So this is helping me to understand the typical order size. So we can make a strategy such as the bulk discount. Lastly, to determine the minimum and maximum price. So here we can see the minimum price is 8 and the maximum is 300. So this is helping us to understand um, uh, various selection, and this might also help us in analyzing pricing strategies or further comparison. Then count the total number of merchants and operating in each country. So to do this, I joined country and merchants on country code, and lately I use the total merchants order by in descending form. Here we can see France and Japan has the highest total merchants. So both France and Japan has the highest margin. So we can focus on promoting marketing strategies there. So we may have higher buyer, a high buyer. And also this query help us to understand the margin distribution by region, so we can inform marketing, logistic or regional expansion strategy. And group the orders by their status and count the number of order in each status. So to run this code, I join orders and group by the status update. We can see most of our uh, status updates are in shift, and less were returned, and um, 19 were cancelled. So this is helping us to understand the operation management and customer service efficiency. And as there are 19 and 14 are cancelled and returned, we need to identify the reason why they were cancelled or why they were returned. And group the products by merchants and display the total number of products offered by each merchants. To do this, I count the product ID, then join them on merchant's ID column and group them with the merchant's name. We see that most of the merchants have the same number of total products. So this helps merchants offering more product or potentially indicating market share or sales opportunity. And show the user who have placed more than 3 orders. To do this, I count the order ID, and lately I put an condition called the count must be greater than 3. So we can see most of our users have ordered more than 3. So this is helping us to identify frequent buyer, which is very important in customer segmentation and marketing. Lastly, date, time, operation. First question was to extract the year and month from created data of orders. So to do this, I select order item and extract year from the create at and extract month from create at. So this was the result. We can see most of our orders from the 9 month from 2024. This is helping us to understand, to keep track trends and seasonal pattern. And we can also give discount on this month. So calculate the difference in days between first and last order of each user. So to do this, I used max and min operation, and alias is a day between first and last order. So we can see this result that most of the user have 0 value, which means they are frequently buying. So they don't have uh, uh, any difference in their first and last order. So last is user date part function to extract the data of the week from the create at column for all orders. So I select order ID and date, format the date at with this function and name this day of week. Here we can see most of the orders are from the Wednesday. So that means this is the busiest time. We can also give order on this weekend. So there will be high chance of user engagement. Then SQL join. Perform an inner join between orders and user to retrieve all the orders along with the user full name. So I select the full name and all from the orders and join them with the order on user ID. Here we can see that Alice has status update in processing mostly, and then some shipped, some cancelled. This is helping us to give a comprehensive view of orders and to place them and it is useful for reporting or customer service purchase. And uses left join to retrieve all products and their respective order, including products that have not been ordered. So I did this, and lastly, I ordered this with is null in descending order. So this will help me to identify which orders ID or product quantity are in null, or so this can identify that uh, if these products are unsold or out of stock, or potentially they may be need restocking or promotion, or maybe removal. Then we have a self-join. Uh, I use this code, and after running this, I found this result, which is telling us that Frank Wright and Grace Lee are from the similar country code. So this is really helping us in geographical analysis or segmentation by region. So as they are from the same country, we can say that we can offer uh, more marketing strategy in this country, so more users are engaged in our product. Then subquery. Write a subquery to find the user who have placed order but have not ordered particular order. So first, this code will run who have ordered at least one, and this code is for those who have not ordered a particular product. So here we see these are the people who have not ordered this particular product. So we need to see why they haven't purchased the certain items, and identify the cost, and build a bit more strong marketing strategy. The last is use a quoted subquery to find users who have placed more order than the average number of orders. After running this code, we can see most of the result is null. So we can see we have spotted high engagement user in our e-commerce database. And window function aggregate functions. So calculate the total number of orders for each user using the window function. So I use the count function on order ID, then partition by with user ID. So here's the result. We see most of them have ordered uh, same. So this is helping us to detailed view of each user order count and aiding us in user behavior analysis. And last, calculate the average price of product over all orders using the function. So after running this function, we can see that uh, this is the average price. So the average price is similar in all the products. So this is helping us to find the average product pricing, and this might be helpful for using for pricing strategy. Window function ranking. Rank the user based on the total quantity of products ordered using row number. So with this row number function, an order by product quantity on sum, and we run the sum operation on product quantity in descending order. And here is the result. We see that most of the total quantity is 126, which is user 1, and we rank them 1. And we see user 4 and 5 are tied in second place with the total quantity of 125, which are ranked 2 and 3. So this is helping us to identify the top buyers, top customer by purchasing volume, and use rank to rank products based on their price within each margins. So I run this rank function and partition by margins ID and product price column in descending order. So we found this that margins 1 ID has the highest product ID, which is 10, and the product price is 50, which why this was rank 1. And so this is helping us to understand the product pricing hierarchy within each margins. So, and it is also helping us to identify the competition between each merchant. Determine the dense rank function of orders by their create date. So I use this dense rank function, and uh, order by created at from order table. So I can see that most orders are ranked 1, which means the sequence and timing of the orders are similar, are consistent. And use a person rank function to find the rank of orders by the quantity compared to overall total. So I run this person rank function and total quantity in ascending order. So here is the result. We can see that order 7 has the quantity 7, which is ranking 0, but the highest quantity rank is 0.106 with the 12 total quantity. So this is helping us to understand the higher or lower quantity related to each other. Window function value and analytics. So use this lead function to find the next order. So I run this lead function and found this result, and we see that user ID order was on 9/11. So the next order is possibly is 9/11, 20, 40 minutes. So this is helping us to analyze the pattern and predict the future of the order. So we can see that user ID 1 are frequently ordering. So we should give those users more offer or coupon code. Use leg function to determine the previous order for each product. So I use this leg function on order table and join them with order item on order ID column. So we find that order product ID previous order is null. So this is helping us to analyze order history and which products is in demand. So we can see that product ID is also in function. This is in demanding. Then retrieve the first value and last value of order status for each user. So after running this code, we found that Ali's order has been cancelled, whereas Bob is shipped. So we are actually seeing a snapshot of those users' order journey. And after analyzing this, we need to see which order has been cancelled or returned, so we can understand the user behavior as well. Then find the first value and last value of price in each product category. So after running this code, we found this, that Martins 2 has the cheapest product, which first price is 8, and expensive product is essential oil set 45. So this is helping us in uh, analyzing the price range for product and aiding in pricing strategies. Then case statement, write a query to get a categorized product into low, medium, or high price based on their price. So after running this, we found that we have mostly the medium price range, which is 300 to 150 taka. So our target would be to give offering discount, to offer discounts, so more user will buy this product. Then create a case statement that categorized user as new, regular, and VIP based on the number of orders they placed. After running this code, we see most of our users are VIP, which means they order more than 5, and so we should give them a reward so they keep buying from this platform. So this is helping us in segmenting user for targeting marketing, loyal programs, or prioritizing customer service. Then lastly, we have common table expression. Here we were told to write a CTE to calculate the cumulative total of product order by each user. So that's why we sum the product quantity and we create this temporary commutative order. And this is the product. We see that Alice Johnson has the highest product, and Diana Brown and Emily Clark have tied here. And lastly, use a CTE to find the top 5 user with the highest number of order. So after running this code using the count function, we see most of our users are ordering more than 10, and I use this limit so that I can find the highest number of order. So this is helping us to find top customer, which can be for customer rewards and target marketing. So here is a short summary from all the slides. The first one is our total number of orders per user appear to be very consistent. And then we see most of our users are from Japan, and both Japan and French have the highest number of merchants. So we need to focus in marketing strategy to grab attention. Third is the user one ranked the first with the highest total quantity of 126, followed by user 4 and 5 tied at second place with 125 each. And most of our users are placed order more than 5, which fall into VIP category, which is very essential to focus on rewarding this group. And then our product price range from 8 to 300 taka, which means it offers a very diverse selection that caters to various various customer budgets and preference. Then we have most of the products in mid-range between 300. So we should give a discount offer on those products. So this would lead a higher sale as user may buy more. Then I have also identified the product quantity that need to prioritize restocking this product. And lastly, given the highest rank of 0.0186, I recommend
Okay, thank you so much, Sanjita Akhtar, to present your presentation, to present your works, your slide creation and your presentation building is very much impressive, and your English speaking skills also very much impressive. And when you start a certain point from this starting point, how you can came out from this stuck point, that was very much impressive, and keep it up. And your also the queries, I saw your queries in each and every queries. I think that very much impressive queries are very much authenticity in these queries has. Also the queries are absolutely workable and right query. And also, I have only one doubt is that in the date time operation question, when you're extracting year and month, only you are showing this only extracted date, year and month. Instead of this, please use the related tables. Why we are actually extracting year and month? We are extracting because of some concern, because of some reasons. You know that reasons. No, so because of that, if you use using this by extracting year and month, as well as some related tables with it, like order quantity, number of orders, number of sales, etc., then this was phenomenal. And that part question was tremendous good. The that part query is good. I think that if any of you, those present here, date part question is not, if your date part question is not the right query, then you can copy the query from the Sanjita Akhtar slide. With Sanjita Akhtar slide, the query part, I think that the date part query was the phenomenal. Thank you so much, Sanjita. Now, thank you all of you for presenting your works. And if you have any concern after I stop the recording, you can